Hello AP Calculus students, and welcome to your first lesson video. It's over 1.1 from the textbook right there, and I'm just going to be going over some examples that I think would be helpful for unpacking some new things that maybe we don't know about as it pertains to pre-calculus, and also just review some old stuff that maybe you guys have forgotten about. So, hopping into it, the first section is all about understanding the nature of absolute value. So absolute value is all about just talking about kind of like whatever's inside, we want both the positive value of it or the negative value, regardless of what direction we're talking about. Look at number 6 right now. All right, so over here, I'm going to unpack number 6. We're given the expression 5 minus x inside the absolute value bars. 5 minus x. And we also have this thing if x is greater than 5. And if you'll remember, the x is greater than 5 just represents a domain restriction. It means we're just talking about all the x values that live to the right of 1, 2, 3, 4, 5 on the xy plane. So, if you think about the nature of what this graph would look like, remember, we turned absolute values into piecewise for a pretty good time. I think we spent like 4 days maybe on just turning absolute values into piecewise. And if you remember, it's the zeros of the absolute value where the piecewise breaks apart. So I'm talking about the curly braces where 5 is clearly the place where it's going to split in two different directions. You've got x is greater than 5, x is less than 5 at different points. And then what you would say is, hey, the behavior is just whatever you have inside the bars. So it's like drop the bars and that represents one of these two domains. If you recall, all we got to do is test a point that lives in here. So test something that's less than 5. 0. 5 minus 0. That's a positive 5, which means it retains positive behavior. So this is the one that's just straight up 5 minus x. And if we test a number that's within the domain of x is greater than 5, like say 6, 5 minus 6 represents a negative value. Therefore, we are talking about the negative potential of 5 minus x. The negative of 5 minus x. So if it's the negative of 5 minus x, it's technically negative 5 plus x for that part right there. So now that we've got our piecewise, and we know that the domain is restricted to x is greater than 5, they're saying, hey, if we know this much is true, then we can rewrite this function without an absolute value. Essentially, the x minus 5 portion of the absolute value doesn't exist at all. So we just say, this is not a part of that function right there, because they're already restricting the domain to greater than 5. Which means our final answer for number 6 is, it's just this. They're wanting a variable expression without the absolute value involved. So negative 5 plus x is your final answer for number 6. By the way, if you're just slightly still confused on this when you work through the homework, I would encourage you guys to look at 5 and 7 and then check the answers in the back of the book. I think it'll clarify a lot of things. All right, number 6 down. Let's move on now to another thing, number 10. Number 10. All right, it says solve the equation by factoring. So they give us 15x squared minus 14 equals 29x. So let's check that. Now, the first thing you need to do if you want to solve an equation by factoring, especially if it has that x squared, x constant structure, is you got to recognize this is a quadratic, which means I got to put it in standard form. Get everybody on the same side. Ax squared plus bx plus c equals 0. That's really what you're looking for. All right. Now, factoring, you can do a lot of strategies. You can guess and check. You can do the AC method, which is the one I've often taught. So I'm just going to show you the AC method, and I'm going to try to turn this a little bit more. There you go. So what is the AC method? Well, the AC method is, this is my A term, this is my B term, this is my C term. I am trying to ask myself, what would multiply to give me A times C? So 15 times negative 14 should be negative 210. And then that number has to add up to our B value, which is our middle. Negative 29. So you might want to just pause this and ask yourself what factors of negative 210 might actually add up to negative 29. You just roll through your list. All right, so you guys probably have it. If you didn't get it, remember, the factors are negative 210 and 1, 210 and negative 1. That list pretty much continues for a long time. But again, guess and check. They got to add up to negative 29, which means they got to be pretty far apart, because one's got to be positive, one's got to be negative to create a negative through multiplication. So, let's see here. Right off the bat, I'm thinking 7 times 30 gives me 210. And those would be 23 apart. So I need ones that are just a little bit more than that apart. So maybe ask yourself, okay, 210, does that divide 5? It does, but the difference is 37, so that's too far. Does it divide 6? There we go. 35 minus 6 is 29. So what that means is negative 35 times positive 6 is the split up of the middle. The middle needs to be split up into negative 35x plus 6x. Negative 35x plus 6x minus 14 equals 0. At this point, I think you guys know what to do. You're supposed to factor by grouping. So you group these two together. They seem to share a 5x for both of them. So I'm taking out that 5x. We're left with 3x minus 7 for our first one. For our second group, they share a 2. And that's a positive 2 for both of them. So you take out a positive 2, and you should be left with the same factor that you had from this one. So 3x minus 7. And all of that still equals 0. So now you do the move where it's like, all right, I can factor out a 3x minus 7, but that they both share. But really you can just think of it as, hey, these guys on the outside, they create a factor that is independent of the 3x minus 7. All right. At which point you say, if two quantities, 5x plus 2 and 3x minus 7, are being multiplied by one another, that means that if they equal 0, one of them's got to be 0. You can't multiply, get 0, and not have one of the pieces be 0. So do the calculation, 5x plus 2. Set that equal to 0. And 3x minus 7 set equal to 0. at which point I think you guys know how to get x by itself. Subtract the 2, divide by 5. Add the 7, divide by 3. So you got x equals negative 2/5 and x equals 7/3. All right, I'm going to do, moving on, let's go to number 16 now. And that's at the bottom of the page here. Solve the equation by using the quadratic formula. I just want to make sure that we're on the same page of what the quadratic formula is. I think you guys can do this, but just want to be extra certain. Negative b plus or minus root b squared minus 4ac, all divided by 2a. You're just making sure that you have number 16 in standard form, which it is. You got 3 for a, 5 for b, 1 for c, and then plug in. So that gives us negative 5 plus or minus 5 squared minus 4 times 3 times 1. Divide all that by 2 times 3. Make sure you just simplify this thing inside the root. Make sure, you might want to jot this down. The quantity inside the root is sometimes called the discriminant. All right, the discriminant. And sometimes in math textbooks, they'll give you instructions on talking about the discriminant. And a lot of times students have no clue what they're talking about. But 25 minus 12, 13 in this case, is the discriminant. All right, and then a lot of times, especially at this level of math, we don't usually mess around with decimal approximations unless there's some kind of application involved. So that doesn't have a simplified root to it. It's just root 13 is its simplest form. It could also take on the form negative 5 over 6 plus root 13 over 6. I'm sorry, plus or minus. Either way, either of these would be acceptable. All right, this is a good stopping point for this portion of the notes. So I'm going to stop it and start a new video and clean it up. So I'll see you in a bit.